Hello and welcome to the third section of this course, Ansible Playbooks Advanced Topics. In this section, we're going to be looking at some of the common Ansible playbooks and how we can use them. We'll look at dynamic inventories, the internals, how we can create our own dynamic inventories, and performance enhancements that we can leverage. We'll make use of register to register module output and when to apply conditionals to our playbooks. We'll look at the many different ways in which looping can be performed in Ansible. Next, we'll take a look at asynchronous and parallel execution, the correlation to forks, and the use of alternative strategies. We'll see how we can use task delegation to target alternative hosts for execution. We'll explore magic variables and how we can easily find available variables in Ansible. We'll look at blocks, how we can add multiple tasks to a block, and how these can be used to perform actions based on failed tasks. We'll see how we can use the Ansible Vault for storing sensitive information, how it can be used to encrypt external variable files, playbooks, and also how we can use the Vault functionality in different ways. Finally, the use of multiple vaults. We'll see how we can create custom modules and also how we can create plugins. Hello and welcome to the first video of this section, Ansible Playbook Modules. In this video, we're going to be taking a look at Ansible Playbook Modules, in particular the setFact module, the pause module, the prompt module, the use of the wait for module, the assemble module to assemble various configuration files, the add host module to dynamically add hosts to our running inventories, the group by module, and the fetch module. Ansible is a batteries included framework with over 350 built-in modules covering a multitude of areas and technical specialities. In this module, we're going to explore some of the modules that are available that you're most likely to use in your everyday playbook creation. The first module we're going to look at in revision 1 is the setFact module, which allows you to dynamically add or change facts during execution. Okay, so quite simply, we have our tasks here. Within this, we have a task called setAfact. We're using the setFact module and we're setting a fact. So the variable that we're actually setting here is called our_fact. We're giving it this Ansible rocks value. And here we're using the debug module and we're actually using that variable that we have just set. And if we give this a go, there we have it. So we've dynamically injected a fact and we've consumed it. If we go to revision 2, what we can also do is set multiple facts in one iteration. So what we're actually doing here is we're setting our fact as before. So this is what we had originally, our_fact. And what we are doing is overriding an existing fact. So the setFact module is very versatile. We saw in the first example we were setting a fact. This time we're setting a fact, but we're actually using this to override an existing fact. So we've used that Ansible_distribution before, and what we're using here, we're passing this through to Ginger 2. We're using a filter and we're going to convert the Ansible_distribution to uppercase. And just here we are showing our different facts. So that's going to be the first fact that we're setting. And this one is the Ansible_distribution. So if we run that now, okay, great. So you can see there we have Ubuntu and CentOS, and owing to the filter that we've used, both of these are in uppercase. If we go into the next revision, The setFact module is very useful when used in combination with the task directive of when. And I've seen people use this quite a lot where they set a common set of variables. For example, depending on the operating system, then they use the common variables in their playbook within tasks. So here we have an example of that. We're using the setFact module, and this is specific for CentOS. So set our installation variables for CentOS. We have the same here for Ubuntu, and for each of these facts we're setting values which could relate, for example, to a web server application. If we encountered a CentOS host, these facts would be set. If we encountered a Ubuntu host, these facts would be set. So just for example purposes, we got a slight variation there. We're using port 80, port 8080 here, a different application path, a different user. So we're using Nginx here and we're using root. And at the bottom here, we have this task, which is going to show the values that we've set. So like I said, where I've seen people using these, they would actually then use these values. For example purposes, we're just passing this through the debug module. Let's have a look how it looks. Great. So for our Ubuntu free host, we have these values. And subsequently for our CentOS host, we have the following. Moving into revision 4. The next module we're going to look at is the pause module. As the name implies, it allows you to pause playbook execution for a given period. It allows you to do some other things such as pausing until a specific prompt is acknowledged. Let's try this out. What we're going to do is use seconds here. So we're going to say within our task, we're using the pause module and we're going to just quite simply pause for 10 seconds. And if we run this, we should get the option of ending this early as well. So we run the pause playbook. There we have the prompt, Control and C to continue early, or then Control and C then A to abort. Into the next revision. The prompt functionality of this module is useful, especially if there are tasks that need to be manually verified before continuing, essentially prompting the user to take action. Let's have a look at an example here of how we could do that. So again, using the pause module, and this time we're prompting and we're saying, please check that the web server is running, press enter to continue. And if we execute this, there we have this prompt. So in the background, someone could actually go off, they could validate something manually if there's a desire to do that. Then when ready, they can press enter and the playbook completes. Into revision 6. Okay, so when you're doing things with Ansible, ideally you're looking to be automating, and I can imagine for a lot of you that the prompt module may not be a good option. Instead, you would rather be waiting for a condition and actually checking that that condition comes about. So there is a module specifically for this. So what we're going to look at in this one is the wait for module. And here, what we're actually saying, the wait for module, it's one that's definitely worth you having a look at. There's a variety of conditions that you can implement in this. So here we're saying wait for port 80 to be available. So wait for our web server to be running on port 80. As we know from our previous examples, this should be the case. Yeah, and because it's running, that is completed. Just to prove the point on this, let's actually shut down the web server on one of these. So we've got CentOS free there, and again, using our own tools here, we could just as easily SSH and shut down the service, but we'll use the command line. So we'll use the service module and the arguments, and the name would be Nginx. and we want the state to be stopped. Hopefully this should do what we need. Okay, there's a lot of output. Okay, yeah, state is stopped. Okay, let's rerun our playbook now. What I'm going to do just before I kick this off is I'm going to background it, because otherwise we're going to be stuck in a situation where it's just going to be waiting for the web server. So we'll background this. So we'll use the ampersand there. Okay, so Ubuntu free has come back. We know that that one is running. At the moment it's waiting on CentOS free. And let's use that same command that we did, but this time let's just change the state to started. Okay, so it completed, it started up the service, and then subsequently the playbook that we had running in the background has just displayed the OK for CentOS free, and that has continued. And where I press returned, you can see that this job has just completed. Like I say, there's a variety of states that you can check for on this. So if we do this with the Ansible doc and we look for wait for. Okay, so we were using port there. You can see at the top we've got an option of using host. Some good examples here. A specific process to finish. So here it's looking for a process file, and the state that we're looking for is absent. We can check for other things as well. So waiting for a file to be present there. So /tmp/foo, waiting for that file and giving the message timeout to find file /tmp/foo. Have a little look through, have a play with some of those. It's a very useful module. Into revision 7. Next, we're going to look at the Assemble module. Now, we know that Ansible can be scaled to thousands of systems, and when working on such a multitude of systems, you may also have configuration files that become exceptionally large. So take, for example, a configuration file where you have one entry for every server that you manage. You may prefer to separate your configuration into files for each particular system. This is where the Assemble module comes in handy. It allows a collection of files to be assembled into one file. So we know that the CentOS host is running on a different SSH port. So we're going to use this one as an example. So just looking at the playbook here, what we've actually got, we've got the Assemble module, and the source is this conf.d, and we're setting the destination as sshd_config. And if I just clear this and look at conf.d defaults, so here we've got some sshd defaults that we're going to use as part of our assemble for the creation of a sshd config. Also within this directory we have an example for CentOS1, so a specific host entry there with the user and the port, and it's that customized port of 2222. Now, when the playbook assembles the contents of conf.d into one file, we'll be able to use the output directly. Let's give this a try. Okay, so that should have created an sshd config. It has, so it's combined the default section for us with the section for CentOS1. And now if we were to use this, so let's just try this with the SSH command. We're going to use --F to specify the config, and we'll connect in there as CentOS1. So we know if we just tried to SSH to CentOS1 at the moment, it would fail because it would try using port 22. But by using this, we're using a custom configuration file that has the correct port, and that's connected. Excellent. Next up in revision 8 is the add host module. So this module allows us to dynamically add hosts to our playbook for subsequent plays. So up until now, all of our playbooks have consisted of one play, but for this we're going to use multiple plays. So you can see here, if you recap on the comments, the minus in YAML indicates a list item. This playbook contains a list of plays with each play being a dictionary. This is one play, and then subsequently this is the second play. And what we're doing here in the task section, we're using the add host module, and what we're doing is we're adding our existing CentOS1 into some new groups. So we're going to add it to this ad hoc group 1 and this ad hoc group 2. And remember, like I said, so this is for subsequent plays. When the next play runs, what we're doing is, for our target, we're running it against the ad hoc group 1. So that's the group that we actually created here. And we have a task, and what we're going to do is ping all of the hosts in that ad hoc group 1. Let's try this. And there we have it. So you can see the first play that is executed here, where we've added it to the group. Then the second play, which is running against this ad hoc group 1, and the ping, which has taken place there. Something I want to show you here. So if we go into revision 9, and we take a look at the playbook here. So when using multiple plays, you will commonly see the minus sign, and not only that, not necessarily multiple plays, but in general, you will see the minus sign next to the host entry. And both approaches are valid YAML. When I was actually setting up these examples, I wanted the comments to be as informative as possible. So where I was actually using the comments previously, it makes sense to have this on a separate line. But just so you know, the following is also perfectly valid. And depending on your preference, you may wish to actually have those comments which are informative for other people, or you may just prefer to go in with this approach. Just to validate that it's exactly the same, we will run this playbook. And yeah, that's working as expected. Into revision 10. Next module we're going to look at is the group by module, which is similar to add host, and this allows us to add hosts to a group based on a key that is derived from facts. So let's take a closer look here. So what we're doing within our task, again, we've got two plays here. So the first play, we have our group by module, and what we're saying is we want to group by, and it's custom underscore, and then whatever the Ansible underscore distribution is, filtered through with Ginger 2 using the lower module. So this is going to add any of the CentOS hosts will get added to custom underscore CentOS. Any of the Ubuntu hosts will get added to custom underscore Ubuntu. And here we're actually making use of this. We're saying, right, target the custom underscore CentOS group and ping all of the hosts. Let's give that a try. And there we have it. So this has used our custom group and it's pinged CentOS 1, 2, and 3. Into revision 11, which is our last example here. And what we're going to look at is the fetch module. So the fetch module allows you to capture files from a remote host. And what we're doing here, so we're saying fetch the etc Red Hat release. So in case you're not familiar, so Red Hat -release is a file which contains information about the version when using CentOS or Red Hat based operating systems, and we're fetching this and we're going to bring it back into temp Red Hat dash release. And in a similar way to what we actually saw earlier, when this runs against multiple hosts, it's going to create a directory structure as well. So what we should end up, for example, with this would be it's running against all of the CentOS hosts. So we should see temp Red Hat dash release slash CentOS1 slash etc slash Red Hat dash release. Let's try it out. Fetch playbook. Okay, so that's executed, and if we have a look, actually let's use the tree command for this. I think that will look. There we have it. So you can see the temp Red Hat release, we have the name of the host, then we have etc Red Hat release, and if we just cat one of those, we're using the same release for all of them, so we don't really need to show. And there we have it. So 7.4.1708 core. Okay, so this finishes off this module.